Hello guys, how are you? I hope you are good. So in this chapter we will learn about prime time. So we know that a factor of a number is an exact divisor of that number. Then the multiple is said to be each of the factors. Now we will learn multiples and factors. So let's start it. Multiples and factors. When a number is multiplied by a whole number, the product is called a multiple of that number and the number itself is called a factor of a product. For example, when 3 is multiplied by 4, we get 3 into 4 equals 12. Then 12 is a multiple of 3 and 3 is a factor of 12. We also know that 3 into 4 equals 4 into 3. Therefore, 4 into 3 equals 12. So, 12 is a multiple of 4 and 4 is a factor of 12. We can say factor. A factor of a number is an exact divisor of that number. Multiple. A number is said to be multiple of each of its factors. Example, let us find all the factors of 20. We find all possible pairs of numbers whose product is equal to 20. We have 20 equals 1 into 20 equals 2 into 10 equals 4 into 5. Thus, each of the numbers 1, 2, 4, 5, 10 and 20 exactly divides 20. Thus, 1, 2, 4, 5, 10 and 20 are all factors of 20. So, 20 is a multiple of each of the numbers 1, 2, 4, 5, 10 and 20. Remarks. 1 is a factor of every number. 2. Every number is a factor of itself. 3. 1 is the only number which has exactly one factor, namely 1 itself. Common multiples. Consider the following table of multiples. Clearly, each row contains multiples of the first number in that row. Thus, the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30 and the multiples of 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. We denote that a few numbers appear to that rows. For example, 12, 24, etc. encircled. Also, we have all numbers like 36, 48, etc. in both the rows if we extend these rows. Such numbers which are multiples of both 3 and 4 are known as common multiples 3 and 4. We can show the common multiples of 3 and 4 up to 40 pictorially as below. You will notice the process of finding the multiples of a number and that of finding common multiples of two or more numbers is always in less. Common factors. Two friends, Elon and John, play the game of jump jackpot. 1. Elon has large chunks of treasure and John wishes to get all of them. Elon places treasure either at all at one number or in parts on several numbers on the number it. 2. John has to select a jump size. He begins from 0 and jumps in multiples of the selected jump size. He gets the treasure if he lands on the number where Elon placed it. 3. Suppose Elon placed all the treasure at number 24 and John selects 4 as the jump jackpot size. Will he get a treasure? Clearly, John jumps to numbers 4, 8, 12, 16, 20 and 24. He gets a treasure as a hands on 24. Similarly, John will get the treasure for each of the jump signs 1, 2, 3, 4, 6, 8, 12 and 24. All these numbers are the factors of 24. 4. Now suppose Elon plays the treasure in two chunks, one at 18 and the other at 24. Let John again select 4 as a jump size. Will John be able to get both the chunks of the treasure? With 4 as the jump size, John will not be able to get a treasure up to number 18. This is because 4 is not a factor of 18. Now, suppose we select 6 as the jump size. This time we will be able to get both the chunks of treasure. This is because 6 is the factor of both 80 and 24. We say that 6 is a common factor of 80 and 24 both. The possible jump size that John could have selected in order to get both the chunks of treasure at 18 and 24 were 1, 2, 3 and 6. These numbers are the common factors of 80 and 24. Various types of numbers. Even numbers. All multiples of 2 are called even numbers. Thus, 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. are all even numbers. Odd numbers. Numbers which are not multiples of 2 are called odd numbers. Thus, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, etc. are all odd numbers. Prime numbers. A number which has exactly two factors, namely 1 and itself, is called a prime number. Thus, 2, 3, 5, 7, 11, 8, 13, 17, 19, 23 and 29, etc. are called all prime numbers. Composite numbers. A number which has exactly two factors, namely 1 and itself, is called a prime factor. Thus, 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29 are all prime numbers. Composite numbers. A number which has more than two factors is called a composite number. Thus, each of the numbers 4, 6, 8, 9, 10, 12, 14, etc. is a composite number. Important facts. 1. 1 is neither prime or composite. 2. 2 is the smallest prime number. 3. 2 is the only even prime number. All other even numbers are composite numbers. Finding prime and composite numbers from 1 to 100. A method for finding the prime and composite numbers from 1 to 100 was found by the Greek mathematician Eratosthenes. Under this method, we proceed according to the steps given below. 1. Prepare a table for numbers from 1 to 100, taking 10 numbers in each row, as shown below. 2. We know that 1 is neither prime nor composite, so we separate it out by making a box around it. 3. Encircle 2 as the prime number and cross out every multiple of 2. 4. Encircle 3 as the prime number and cross out every multiple of 3. We need not mark the numbers which have already been crossed out. 5. Encircle 5 as a prime number and cross out every multiple of 5. We need not mark the numbers which have already been crossed out. 6. Encircle 7 as a prime number and cross out every multiple of 7. We need not mark the numbers which have already been crossed out. 7. Continue this process till all the numbers up to 100 are either encircled or crossed out. Sieve of Eratosthenes. Note, 1 is neither prime nor composite. All encircled numbers are prime numbers. All crossed out numbers are composite numbers. Thus, all prime numbers from 1 to 100 are this one. Twin primes. A pair of prime numbers having a difference of 2 are known as twin primes. Pairs of twin primes between 1 and 100 are 3, 5, 5, 7, 11, 13, 17, 19, 29, 31, 41, 43, 59, 61, 71, 73. Prime triplet. A set of 3 consecutive prime numbers differing by 2 is called a prime triplet. The only prime triplet is 3, 5, 7. Coprimes. The numbers are said to be coprimes if they do not have a common factor easily other than 1. Remarks. Two prime numbers are always co-prime to each other. Two co-primes need to not to be prime numbers. For example, 4 and 9 are co-primes. The first common multiple of two co-prime numbers is equal to their product. 1. The only common factor of 3 and 5 is 1. 2. The only common factor of 4 and 7 is 1. 3. The only common factor of 16 and 25 is 1. Similarly, 8, 15, 9, 16, 10, 13, 11, 15, 15, 22, etc. are all examples of pair of co-prime. String art using co-prime numbers. String art is used to create a variety of patterns by weaving thread between pegs fixed on their wooden board. Consider 12 pegs fixed in a circular pattern. If we start from the 12th peg and taking a thread gap of 3, move our thread, we come back to the 12th peg, leaving a lot many pegs without thread. Consider 15 pegs fixed in a circular pattern. If we start from the 15th peg and move with a thread gap of 3, we again come back to the 15th peg, leaving many pegs without thread. Consider 15 pegs fixed in a circular pattern. If we start from the 15th peg and move with a thread gap of 4, we will cover each and every peg with thread before coming back to the 15th peg. Take 16 pegs fixed in a circular pattern. If we start from the 16th peg and move with a thread gap of 5, we will again cover all the pegs before reaching back to the 16th peg. Look at the beautiful designs created by the thread and coverage of all the pegs by the thread in figure 3 and 4. The thread will cover all the pegs when the number of pegs will be at the thread gap are co-primes. The numbers 4 and 15 are co-primes. Similarly, 5 and 16 form a pair of co-primes. Checking if two given numbers are co-primes. Rules. Find all possible factors of each of the two given numbers. If 1 is the only common factor of the two numbers, then the given numbers are co-primes. Examples 1. Consider the numbers 16 and 21. We have 1 into 16 equals 16, 2 into 8 equals 16, 4 into 4 equals 16, and 1 into 21 equals 21. 3 into 7 equals 21. The factors of 16 are 1, 2, 4, 8, and 16. And the factors of 21 are 1, 3, 7, and 21. Clearly, 1 is the only common factor of 16 and 21. Therefore, they are co-primes. 2. Consider the numbers 15 and 91. We have 1 into 56 equals 56, 2 into 28 equals 56, 4 into 14 equals 56, 7 into 8 equals 56, and 1 into 91 equals 91. 7 into 13 equals 91. The factors of 56 are 1, 2, 4, 7, 8, 14, 28, and 56. And the factors of 91 are 1, 7, 13, and 91. Clearly, 1 and 7 are two common factors of 56 and 91. Therefore, they are not co-prime to each other. Perfect numbers. If the sum of all the factors of the number is 2 times the number, then the number is called a perfect number. Example, we shall show that each one of 6 and 28 is a perfect number and a 10 is not a perfect number. 1. All the factors of 6 are 1, 2, 3, 6, and 1 plus 2 plus 3 plus 6 equals 12, 2 into 6. Therefore, 6 is a perfect number. All the factors of 28 are 1, 2, 4, 7, 14, and 28. And 1, 2 plus 4 plus 7 plus 14 and 28 equals 56. Thus, 28 is a perfect number. 3. All the factors of 10 are 1, 2, 5 and 10 and 1 plus 2 plus 5 plus 10 equals 18 not equals 2 into 10. Clearly, 10 is not a perfect number. Divisibility test for 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. A number is divisible by 2 if its one digit is 0, 2, 4, 6 or 8. 1. Each of the numbers 30, 52, 84, 136, 2108 is divisible by 2. None of the numbers 71, 83, 215, 467 and 629 is divisible by 2. A number is divisible by 3 if the sum of its digit is divisible by 3. A number is divisible by 4 if the number formed by its digit in tens and ones place is divisible by 4. A number is divisible by 5 if its ones digit is 0 or 5. Each of the numbers 65, 195, 230, 310 is divisible by 5. None of the numbers 71, 83, 94, 106, 327, 148, 279 is divisible by 5. A number is divisible by 6 if it's divisible by each one of 2, and note that 2 and 3 are the prime factors of 6. Each of the numbers 18, 42, 60, 114, 1356 is divisible by 6. None of the numbers 21, 25, 34, 52 is divisible by 6. A number is divisible by 7 if the difference between twice one's digit and the number formed by the other digits is either 0 or a multiple of 7. A number is divisible by 8 if the number formed by its digits in hundreds, tens and ones places is divisible by 8. By 9 if the sum of its digits is divisible by 9. By 10 if its one digit is 0. Each of the numbers 30, 116, 690, 720 is divisible by 10. None of the numbers 21, 32, 63, 84, etc. is divisible by 10. By 11 is the difference of the sum of its digits in all places and the sum of its digits in even places starting from the ones places is either 0 or a multiple of 11. General properties of divisibility. If a number is divisible by other numbers, then it is divisible by each of the factors of that number. If a number is divisible by two co-prime numbers, then it's divisible by other product also. Since two prime numbers are always co-prime, it follows that if a number is divisible by each of one of the any two prime numbers, then the number is divisible by their product. If the number is a factor of each of the two given numbers, then it must be a factor of the sum. If a number is a factor of each of the two given numbers, then it must be a factor on the difference. If A is divisible by B, then A is divisible by every factor of B. If A is divisible by two co-primes B and C, then A is divisible by B into C. If A is a factor of each one of B and C, then A is a factor of B and C. If A is a factor of each one of B and C, then A is a factor of B minus C. Prime factorization. Prime factor. A factor of the given number is called a prime factor if this factor is a prime number. Example, 2 and 3 are the prime factors of 12. Factorization. To express a given number as a product of prime factors, it is called prime factorization or complete factorization of the given number. Unique factorization property. Every composite number can be expressed uniquely as product of primes except from the order of the primes. Find the prime factorization of 90. We use the division method as shown below. Hence the prime factorization of 90 is 2 into 3, 2 is 5. Find the prime factorization of 1260. Hence, the prime factorization of 1260 is 22 into 3, 2 into 5 into 7. Find the prime factorization of 1729. The prime factorization of 1729 is 7 into 13 into 90. Express 20,570 as the product of its prime factors. Using the division method, we get 20570 in 2 times, 102855 times, 2057 11 times, 187 11 times, 17 17 times, 1. 20,570 equals 2 into 5 into 11 into 11 into 17 equals 2 into 5 into 11 square into 17. Prime puzzle. The puzzle consists of a 3 into 3 empty grid. We have to fill in prime numbers in the grid in the way that the product of all the numbers in any row is equal to a number provided a right of that row. Also, the product of that number, if any column, is equal to the number provided at the bottom of that column. Complete the prime puzzle given below. Solution. Prime factorization of that number in the first row is 242 equals 2 into 11 into 11. And the prime factorization of the number in the first column is 99 into 3 into 3 into 11. 11 being common to the first row and first column will fill in the top left cell. 130 is not divisible by 11 but 385 is divisible by 11. So the other number 11 is a factor of 242 will fill the third cell in the top row. Proceeding in this manner, we get 11, 2, 11, 3, 13, 15, 3, 5, 7, 242, 195, 105 and that more. If you watch this video, then please like, subscribe, share, comment and perform to press the bell icon. So, let will be completed till you next time. Jai Hind.